Okay, you're asked to solve this quadratic equation, x squared plus 3x minus 28 equals 0 by the process or the technique of completing the square. This is probably leading up to deriving the quadratic formula. You can always use completing the square to solve a quadratic equation. Here's the technique. Assuming that we have a leading coefficient of 1, get this constant term to the right side of the equal sign, in this case by adding 28 to both sides. And then we want to fill in these question marks with a number that makes this left side a perfect square trinomial. And as long as this leading coefficient is a 1, what you do is take half of this number right here, 3 halves, there's half of 3, and square it. And that's 9/4. And that's the number that completes the square or makes this trinomial a perfect square trinomial. But if we add 9/4 to the left side of the equal sign, we have to add 9/4 to the right side. Now this perfect square trinomial can be written as a binomial squared. And that's always just going to be x plus or minus, depending on whether this value of b is positive or negative, half of that, which was this number right here, 3 halves, or the square root of 9/4 is 3 halves. But you have to pay attention to whether this is a plus or a minus. Over here, you can convert 28 to an improper fraction, 112/4 plus 9/4 is 121/4. Now, the whole point is at this point, you can use the square root property. Take the square root of both sides. If these numbers are equal, their square roots will be equal. But we have to write plus or minus because the square root of 121/4 can either be plus or minus 11 halves. And there's what we have right there. Subtracting 3 halves from both sides to isolate the x. There's your two answers. X sub 1 is one of the roots of this polynomial function, if you wanted to call it, refer to it as that, and x sub 2 is the other one. Note that you could have solved this equation quite easily by factoring, searching for two numbers that multiply to give a product of negative 28 and have a difference of plus 3. So 7. This is negative. This is positive. You check using FOIL, you do get x squared plus 3x minus 28. And so setting each factor equal to 0, x is negative 7 or x is 4. Now here's a derivation of the quadratic formula, just so you can see the slight difference. Here's the quadratic equation set equal to 0. Take the constant term to the other side. Here's the extra step that's required. You have to divide every term by a so that this leading coefficient is a 1. So I've divided every term by a. Now we go through the process of completing the square. We have to have half of this number squared. Well, half of that is half of b over a, which is just b over 2a. But b over 2a squared, the quantity squared, is b squared over 4a squared. That's what I added to both sides. Now this is a perfect square trinomial because they had a leading coefficient of 1, and this third term is half of this coefficient squared. So I can rewrite this as x plus b over 2a, the quantity squared. I can get a common denominator here by multiplying numerator and denominator of this first term by 4a, so that I can add the fractions, and I change the order. And now you can see how we're starting to get to the quadratic formula. take the square root of both sides. The square root of this denominator is 2a. And I can subtract b over 2a from both sides. They both have a denominator of 2a, so it can subtract or add the numerators. There's the quadratic formula, and there's where it comes from, the process of completing the square on this guy. Okay, hope that helped. If you have any questions, post a comment.